Cool. So yeah, thanks everyone. I'm Chris. I'm going to talk about automated versioning, specifically using semantic release and the Python semantic release. So nowhere I'd ever worked had used it. Like, has anyone used it in the room? Has anyone used it at work? Or? Okay, some JavaScript. Okay, yeah. So it's some. And so yeah, the idea for us was to try and get from a place where like release management was slow and painful, as ChatGPT thinks, to a much more automated version. So just a few assumptions then. We had we want to version our releases. We don't just want like free form, everyone's just using the header main or anything. We're going to use semver, not like timestamps or dates like some of the Microsoft APIs, for example. Like version numbers are free. Like it really doesn't cost anything to bump a version number. And if we end up with really high version numbers, like no one's scared of that. There's no like reluctance to bump a version because the version numbers are semver and we know what things are going to be compatible with what. And that they're not coupled to marketing. So like it's no problem if we bump the API version or the front end version like quite a lot of times, like for an internal thing, because the marketing department or sales can still call it the same version of the product, and they're separate things. We want to release really frequently, and we don't want to be saving up like months of changes and then having like a big release day. We just kind of want to just be releasing stuff as it's ready, just to show kind of like continuous delivery and improvement in value. We're all happy to use loads of automation. Like we're not scared of automation, like it's going to put us out of work. Like automation just lets us do more. And everything's based on Git for version control, because that's what the tools are built on. So like the problem we had then is like from the start. So I worked for a startup in Belfast and called Buffalo Grid. And like from the start, we went quite in on CI and CD for like linting, unit testing, all our deployment for infrastructure and deployment for code. And so that's triggered on, so if you merge to main, we deploy automatically to the dev environment. You tag main, we deploy to production. So like that bit, once you got there, was really quick and painless. But actually getting to like the point when you were ready to tag a release ended up there being a lot of friction. So you have to prepare the release notes, the changelog. You maybe have to update your pyproject.toml file or your package.json files. And actually, especially at the start where we were many months away from having a hardware ready or to actually having a customer, like you might just forget to release stuff like for ages because no one's asking for it really. Like everyone sees you're doing stuff. And then suddenly you end up with like massive releases at the head of the dev branch, which you need to put into production, and maybe you can't even quite remember what's there. And so yeah, so that kind of friction just meant it became like a real chore, and that kind of becomes self-perpetuating almost. So we tried a couple of things that didn't really work. One was Towncrier. This is a Python CLI tool. So whenever you sort of push code, you can include a little news fragment file with a summary of what you did. And when you want to update your changelog, you run the CLI. It grabs all your news fragments, makes you a nicely formatted block at the top of your changelog. Doesn't have anything to do with versioning though. You've still got to work out like what version number you want to put there. Is it a major, a minor, or a patch increment? And people just forget to put news fragments in when they push their code. And you can have something in the PR template, check that it's there, but it's not foolproof. So that didn't really work. We tried change sets next. So this doesn't really have any Python support. It's really for JavaScript. It's a CLI tool, and then a GitHub bot runs in GitHub Actions that Atlassian maintain. So it's an interactive CLI tool. You run npm run change set or something like that, I think it was. And there's a little interactive menu you can complete on the CLI. So you say whether it's a major, a minor, or a patch release. You put in a description of the changes, and it creates a little file which calls a change set. In GitHub, if you've got the bot installed, once you've pushed your code, raised a PR, the PR will actually, like the bot will post a comment if there's no change set saying, hey, there's no change set here. Are you sure about that? Or it'll tell you that there is a change set and that this is the type of release that will generate. The bot maintains a branch with a PR to your release branch the whole time. With an up-to-date changelog file and an up-to-date version number at the top, so it's sort of an improvement on Towncrier. It always misses updating the lock file for JavaScript repos. So then you've got a package.json and a lock file which are out of date. And also you need to merge the bot's PR into your release branch and then sort of check what the version number was and create the tag and actually do a release. And so again, that can get missed. So it was definitely an improvement, but wasn't great and only worked really in the JavaScript libraries and repositories. So what worked for us, which some of you said you use already, is semantic release, and then it's Python equivalent, Python semantic release. So that this completely automates versioning. and it uses the commit messages rather than little files stuck in. So there's good supporting tooling, which I'll talk about a bit in a moment, in the form of commitism and commitlint. And you use the commit messages to generate the changelog. So the idea is that every commit message you have on a feature branch, which you're going to merge into a release branch, has a well-defined format that can be parsed, and the tooling then works out, is this a major breaking change, a minor, or a patch release? It'll update in the Python case, your pyproject.toml file, or in the JavaScript case, your package.json and package.lock.json in this case. And then it can actually automate releasing to PyPy, to artifact repositories, and to GitHub releases. The integration is a bit more complicated. I think for us, it was definitely worth it. And maybe a positive or negative, everyone gets kind of more familiar with interactive rebasing. Because maybe as you're working on your feature branch, like you have a work in progress commit or a debug commit, or it's the end of the day and I want to push my code commit. But when you actually come to raising a PR and want to get that into the main branch, every commit is potentially going to appear in the changelogs and has to pass linting if you've something like commit lint installed. So just rebasing your commits and squashing and picking messages is pretty handy. So the supporting tooling was all JavaScript. I couldn't really find good Python equivalents, but so actually all our repos across, whether it's the embedded system build system or a Python repo or a JavaScript repo, they all have a really small package.json file with a couple of tools in. So commitlint, you can pick a format for your commit messages. I love a good default, and you just don't have to think about it or argue about it. So conventional commits is the one it proposes. So you have this type. So this one's a feature type, and a scope, what does it affect? A short description, then a longer body, and optionally you can put in a footer to link it within GitHub as to what the PR is going to close. And then commitlint will enforce that. So when you push code on the feature branch, we have it set up that actually if you've not kept that format, you'll get a failure and you can't merge that. Commitism then is a bit like change sets. It's an interactive CLI tool. You run, say, npm run commit instead of git commit, and you get an interactive menu where you can select that scope and enter the various parts that will match the conventional commit format. So for Python semantic release then, for integrating into a repo, there's a few bits you need to do. In your pyproject.toml file, you first set the version. So this is the version of your code in the repo, and this will get maintained and updated by semantic release. We set Python semantic release as a dev dependency, and then it then gets its own config section in pyproject.toml. So we tell it where to find and update the version number. So it's going to get it in a toml file, pyproject.toml, and then the path. We have to tell it a release branch. So it has sort of protection. If you try and run publishing from a non-release branch by accident, it's not going to release it. It'll tell you this isn't the release branch. You can optionally upload to PyPy if you provide credentials. We don't. These are private repos for us. Upload to an artifact repository, and then you can upload your release, which we do. So when we run a publish, we upload to GitHub and create a release in GitHub releases with the code attached. We need to tell it the build command for building the artifacts to attach to the release. Where to get the source of the version. So for us, it's the tag in GitHub. Not the commit history. And then we're going to commit the version number. So that just actually makes it, update pyproject.toml with the new version number. And then we can use a commit message because these files are going to get added to our release branch. So we can use the sure scope to make sure semantic release ignores it. And the skip CI at the end is recognized by GitHub Actions. And so it'll skip any CI so you don't end up sort of recursively running deployments. So all you need to do then really is just have somewhere in your CI pipeline, poetry run semantic release publish. And now what that's going to do then is it'll parse through your commit history. It's going to update your changelog file with all the entries from the commit messages. It'll calculate a new semver tag based on those. It's going to push all the changes to your version control system. So, then it'll run the build command if you want to, and also then attach all those files to your GitHub release. So possibly legible at the back. I'm sorry about that. get it into GitHub Actions. So we have a job in a lot of our workflows called release. We check as an extra check. We only run it on our release branch. And as an output, we're going to store the new tag as an output so that we can do other jobs and steps conditionally if we make a release. Really important, when you check out the repo, you have to not persist the credentials. Otherwise, the GitHub, the sort of checkout in your action pipeline will have like some non-admin credentials, which kind of override any that you might try and set up, and you'll not be able to push back to your main branch. Then we check out Python, set poetry up. We need to set up 2 tokens. The secret token that comes just with the workflow that has permission to read the current repo. And also we need like an admin scope token, so like a pat with repo scope, so that we can push to the main branch our updated pyproject.toml file and create the commit, skipping the requirement to have a PR, which we have in our branch protection rules. So we just have to set up some git config. We can pull out the version. So semantic release print version will tell you what version number it's going to make ahead of time before it actually makes it. So we can store this. We have the publish command, which actually does everything. So that line is the one that creates the new commits on your main branch and creates the release tag. And then we can store that tag in an output for the job, which means we can have a job later on in the pipeline, which can conditionally run if there was a release version. And then we can do whatever we want then, having switched to our new tag, because even though we've pushed new commits to the head of main, from GitHub Actions point of view, the head of main is always the commit that triggered it. So you need to make sure you actually switch. Just checking out main again doesn't get you the new commits, which include the updated version numbers. So obviously there's not that much config in that, but there is a little bit. So what we did, it's kind of handier to have a private action repo where you can create a Docker action, which has that workflow in it. And then literally you can just copy and paste this kind of job as a release job into any other repo that you want to use it. And that way, if you want to change some logging or fix an error or a bug you found or something, you just have to do it in the one place and just update the version numbers. It's just a little bit easier. So fairly short talk. So the impact for us then was that almost every merge now results in a release and a deployment in some cases. So for anything that's like pretty much stateless, like the front end or the like embedded system components that even when they get released to production, actually like they don't end up on hardware in front of customers. They just end up on hardware in our office in an integration test rig. Every commit just goes live to production straight away, because if we break the front end, we have automated testing, which tells us really quickly, and then we can just fix it. And again, we can release it really quickly. Some of the more stateful stuff, we still only would release to dev automatically. So that would be like infrastructure, so Terraform pipelines, backend APIs that actually interact with databases in our ETL pipeline, but then just have a workflow for releasing to production. So our merge to the release branch would have generated the actual release and the tagging and the changelog and everything, and to push it out into production infrastructure is then just a manually triggered workflow after it's been tested in dev. And then, the result is that we spend hours less on releases, and actually the team of sort of 4.5 can release at times multiple times per day, because really once you're happy with the code and it's been through code review and tested, it's a single button press and it's live. So it'd be interesting to take any questions, or if anyone's opinions on their experiences with it, that would be good to hear as well. Yep.
Is poetry a built-in thing? I've never done it before.
No, so we would install it in the pipeline, like using pip. So we do like pip install poetry. I think they provide like they have like a shell script install as well. Like you can just curl a script that will install it.
Have you used Envoke?
No.
I was going to ask it. But if it's similar to poetry at all.
Invoke a way to interact. Modifying pretty different from different poetry is kind of more like defining. Actually makes sense for building so kind of a version of it.
Okay.
I
Yeah.
about the workflow. So
Yeah.
So you start with like 1.0 and
Yep.
you want to do so 1.1.
Yep.
So you run this workflow, it detects it works out that it needs to be bumped up to 1.
Yeah, so you don't decide you want to release 1.1. You have some commits that you've made, and in the commits you've picked a scope. So you've said like it's CI or build or docs or a feature or performance, and then in doing that, then in the commit body, you may have at the start of the line written breaking in capital letters. The tool will analyze when it analyzes the commit history. If it finds a perf or a feat, if it finds a feat, like a feature, it will generate a minor. If it finds a perf or a fix, it'll be perf or a fix is minor, patch. Feature is minor, and if you've written breaking on any kind, then it'll be major. You may have had like several commits in your branch before it got merged, and there could be a mixture of them, and it'll generate the appropriate one for you.
Basically combining those together.
Basically combine them. So you've got like 3 fixes, 2 features, and a breaking change. So you get a major.
So when it's working, and it works this out in that workflow there. So
Yeah, so like this line here that runs on the main branch. So
it updates the PyProject.toml.
Yep. So based on the config you've got here. So in the top right, that's version_toml. There's a few other options. You don't have to use toml. You can have version underscore something else. You can have a special file where it is as well. And then if you use the toml one, you provide a file name and a path.
And it does this after the build? Or before you do poetry build, does it do that after that?
It's all in that workflow. So I think it updates the number first. Then it does the build and generates you a wheel. And then it gets your source and zips it. And then when you get to this point for GitHub, if you're doing a GitHub integration, there's some built-in for GitLab and maybe a couple of other things, but for GitHub, then it'll create a tag on your release branch with the same number as this. And then a GitHub release, it'll populate the release with the changelog it generated here, and then it'll attach the wheel and the zipped source.
And in that commit, the PyProject.com will be updated, the poetry lock file would be updated.
Yes,
as well.
yes, yeah. So it's all correct. The thing that we actually missed when we did it to start with is when we then got to the deploy, for some of our repos, we built like a Docker image, but we were just checking out main. But actually in GitHub Actions, that main is like the state of the branch before you started here. And obviously you've added more commits. So then actually we just have to check out our tag and then use that code for building an image. Otherwise our images were tagged with our new number, but the code inside, like in our Swagger docs, would always report the previous version. No worries.
I just realized that's exactly the problem with like semantic-release builds.
Yeah. It was useful.
Cool.
Yeah. So
just last thing.
yeah.
Is this like a
So it's different things. So it's like, yeah, we've no open. Okay, we've one GPL licensed repo, so that one's open, but everything else is all internal. So it kind of depends. Like once you've got the release tag, it's up to you if you do anything with it. So like we do different things with it in different places. So like for our front end, like dashboard code, we just immediately deploy it to production. And if the site's down, like an alarm will fire within 5 minutes, and then we can try and fix it. For like our embedded system, like we build the artifacts, we push them to Azure storage, we push them to our over-the-air update systems, like artifact repository, and we just deploy it to one like physical integration unit. But customers don't get that one, because if it went wrong, it would go really wrong. And then yeah, like for the stateful stuff, we only actually push it to dev, just in case something slipped through that really screws the database, and then we can test it in dev, and then we just have a workflow. And that workflow is really, really simple. It's just like pick a tag, trigger, and then that deploys to production. But all the versioning stuff and the editing files and making commits is all done by that point. You don't have to do anything manual.
How long does it take you to beat people into submission and not having commit messages like fix me, still not working?
It just started enabling commitlint and stuff, and then no one could get anything
No
in.
one can get anything.
No, if it doesn't match, then the pipeline fails. And I go, like, well, my code's fine, your code's fine, but the commitlint says it's not getting merged, so fix it. And yeah, there's no choice.
I'm sure that wants some friends.
Yeah, well, there's a small team, and like it kept coming up in retros highlighted that releasing was really annoying people, and people were getting annoyed with being told, hey, can you put that out to production? And then it was taking them like a whole, like half a day to work out how to write the changelog. So like, it was like a known pain point. So people were quite accepting of bringing in something to save them effort.
So I know this is not the right, but again, for a similarly small thing, but not necessarily downstream. In fact, in theory, you can just apply the same thing, but not necessarily on every commit that could affect the merge level and then force commitment on the squash.
That's what we do.
Yeah.
Right.
We force squash commits and we validate the PR title. So we get home action.
Okay, yeah, we stopped doing squashing and moved to rebasing everything, but making sure all the feature branches passed commit linting before you're allowed to rebase the commits into main.
That break the bill in the you open the PR and it links the commit at that point? Or
Yeah, so no, so no pre-commit hooks, but on the feature branches, we've like Flake8, iSort, MyPy, Black, and commitlint. And if any of them fail, you can't merge the PR. And then on the main branch, we run all of those except commitlint, just because the way it worked, it was a bit awkward. We just check the code passes all the linting and everything out. But it shouldn't ever have got merged without passing commitlinting. Cool. Thank you.